Hello and welcome to today's class. For this class, we'll look at the concept of electrostatic. From the word electrostatic is simply the combination of two words, electro and statics. Electro basically has to do with electricity, right? Charge, right? While statics has to do with a body or a system at rest. So now to combine these two concepts together, what's electrostatic by definition? Electrostatic is simply the study of charge and charge system at rest, right? So the study of charge and charge system at rest is said to be electrostatics. It cannot be defined as a branch of physics that studies the properties of stationary or slow moving electric charges. So I'm saying that electrostatic can also be defined as a branch of physics that studies the properties of stationary or slow moving electric charges. That's your definition for electrostatic. At this point, when it comes to the concept of electrostatics, there are laws that governs these concepts. Let's look at the several laws of electrostatics. Let's look at some of the laws of electrostatics. Basically, there are just two laws behind electrostatics. The first law is given as like charges repel while unlike charges attract. This is your first law that governs electrostatic, that says that like charges repel while unlike charges attract. That is, if I have two charges, let's say positive charge and another positive charge, these two charges will what? Will repel. That is, they won't combine, right? It will repel in this manner. It will repel in this direction, right? They won't connect to each other because they have the same charges, right? So they won't connect to each other. So it will be something of this nature, right? So I have this. So this is like your concept behind the first law that says that like charges repel while unlike charges attract. For the unlike charges, let's say that I have a positive charge and a negative charge. These two can combine, right, in this form. Observe their combination, right? So I have this, they'll combine in this form, right, in this form. So it's more from positive to negative. So you can see positive to negative. So this is like your concept behind the first law that says that like charges repel while unlike charges attract. As in this case, unlike charges are what they attract. That's the first law behind electrostatics. The second law there is called the Coulomb's law. Coulomb's law, right? Let's state Coulomb's law. All right, Coulomb's law states that the force of attraction between two charges, let's say Q1 and Q2, is directly proportional to the product of the charges and inversely proportional to the square of the distance separated apart. That's how it states Coulomb's law, right? A force of attraction between two charges is directly proportional to the product of the charges and inversely proportional to the square of distance separated apart. So let me just explain the concept behind Coulomb's law. For Coulomb's law, let's say I have charge here. Let's say I have charge Q1 and under charge Q2, and these two charges are separated by a distance r, as you can see. The plane noise is entering the video, so I have to stop. Hold on, let's proceed, please. So I have a Q1 and Q2 and distance apart r. So I'm saying that from Coulomb's law, the force of attraction, these charges, the force of attraction F, these charges Q1 and Q2, we said is that proportional? Is that proportional to the product of the charges? The product of the charges, that's Q1 times Q2. The product of the charges are B. At the same time, this same force again is what? Inversely proportional to what? To the distance separated apart, but not the distance, but the square of distance separated by apart. So F is proportional to what? Q1, Q2. At the same time, that same F is inversely proportional to what? The square of distance separated by apart, which I have this. So I combine these two together. Let me call this one equation 1. Let me call this one equation 2. If I put 1 and 2 together, put 1 and 2 together, I'll have that F, that is F, which is the force of attraction, is that proportional to Q1 times Q2, that's Q1, Q2, and at the same time, inverse proportional to what? This is apart, the square of this is apart, that's R squared. From here, I'll have that F, Q1 times Q2 times 1, I'll have Q1, Q2, all over, this one comes down, R squared. So I have this, R squared. In your normal math, how do you take off proportionality sign? This symbol, I'll introduce equal to a K. For me, I'll have that F is equal to K, Q1, Q2, all over R squared. So I have this, right? So from here, let's try to make K subject. If I make K subject, I'll multiply over 1 here. 1 times this, I'll have K Q1 Q2 equal to what? F R squared. F times K R squared, F R squared. I want to make K subject here. Divide both sides by Q1 Q2. So divide both sides by what? By Q1 Q2. So pick out this one first. K Q1 Q2 equal to F R squared. You said divide both sides by what? Q1 Q2. So Q1 Q2 all over Q1 Q2. This one will cancel this. So the constant of Coulomb's law, K, will be equal to F R squared all over Q1 Q2. Let's get SI unit for constant of Coulomb's law. So the SI unit, the SI unit for constant K is equal to force is measured in Newton, radius is in meter, but having radius square, that becomes meter squared, all over Q1. Charge is measured in Coulomb, right? Coulomb's law, from the word Coulomb's law. So Coulomb C times under Coulomb C. For me, I'll have Newton meter squared over C times C squared. So the SI unit for constant of Coulomb's law is what? Newton meter squared per Coulomb squared. So I can write it as Newton meter squared per Coulomb square. This is simply the SI unit for your constant or Coulomb's law. So I have this here. From here now, if I at this point now, note something at this point. Note that this K you are seeing can be expressed as 1 over 4 pi E naught. Note that K can be expressed as 1 over 4 pi E naught. If this is true, what's this E naught? By the way, E naught is called permittivity of free space. So note that E naught is called permittivity of free space. So note that K can be expressed as 1 over 4 pi E naught. And also, let's go down a bit. Let's move down a bit. And also, this value that we said K should be equal, can be equal to 1 over 4 pi E naught. This can also be expressed as what? 9 times 10 to the power 9 Newton meter squared per Coulomb square. Constant, the SI unit is what? Newton meter square per Coulomb square. So I have this as my time. So either I can express K in terms of this or in terms of this figure. So that's your concept. So if I go back to this equation, let me call this one equation aesthetics, right? If I go back to equation aesthetics, we have that first F is equal to K Q1 Q2 all over R square. This formula is the formula for calculating the force of attraction between two charges separated by distance apart, separated by the square of distance apart. So I have this. From here, what is K? We said K can be expressed as what? 1 over 4 pi E naught. From here, I'll have that F is equal to, make K a standalone, I'll have that K times Q1 Q2 over R square. But we said that K is what? 1 over 4 pi E naught. So I'll have that F is equal to, what's K? 1 over 4 pi E naught times Q1 Q2 all over R square. If I have to combine these two together, what do I get? If I have to combine these two together, what do I get? All right. From there, I'll have that the force of attraction F can be expressed as 1 times Q1 Q2. That's Q1 Q2 all over 4 pi E naught R squared. So these are my mathematical expression for the force of attraction between two charges separated by distance apart, separated by the square of distance apart. So I have this. These are your expressions for Coulomb's law. So this is like what you need to know when it comes to Coulomb's law. Let's take some few examples and then we'll solve together and look at how to handle problems when it comes to electrostatics. Hold on guys a little bit. Let me tell you what you need to know. Actually, I'm running a membership program, right, which can help you a lot. So to join my channel membership, it's quite easy task, right? As you can see the icon I'm showing you here, that icon is my membership opportunities, which you can access monthly. So I'll drop the link to the membership in the description of this video, right? So just click there, click on the membership link, so you purchase the one you want. So I have for JAM and YA classes, and also I have for 100 level students. So whichever one suits you, click there and subscribe. If it, sorry, perhaps click there and purchase the one of your choice. Anyone you purchase, there are several advantage videos that I will not allow people to see. So it's for only those who have joined the channel that will have access to those even advanced problems. And also, I do help students from different countries to solve their assignments. So if you're in UK or abroad or Canada or anywhere you are in the world and you want me to help you do your assignments, you can simply check me. You can simply visit me on my WhatsApp number, or also share this complete video. I'll drop a link to a website there. In the website, you can register with us and you let us know which assignment you want us to help you to do. Do well to join the channel. Thank you. You can proceed with your learning now. Example 1. Let's do example 1. It says that two forces of attraction between two charges Q1 and Q2 separated by a distance of 2r is dash. So the force of attraction is what I'm looking for. So I'm looking for F, right? But between two charges, the charge is given there is the charge is here is given as what? Q1 and Q2 separated by distance. The distance here, the r there is not just r, but distance here is 2r, right? Is my distance there. So I'm going to express this stuff in terms of my normal expression for force of attraction. So the force of attraction, by the way, I have two charges, Q1 and what? And Q2. The distance here is not just r, but what? 2r is my distance, right? Is my distance. So the force of attraction, F, will be equal to what there? As we know, K, right? K, in this case here, Q1, Q2 are my charges. So I have Q1, Q2 all over. The distance says just r squared. Here is not r, is what? 2r. So it becomes 2r. Mind you, I'll have a square there. From here, I'll have that F is equal to K Q1 Q2 all over. Take this one to indices. I'll have 2 to power 2, then r to power 2. These indices. From here, I'll have that the force of attraction that I'm looking for will be equal to K Q1 Q2 all over 2 square is 4r squared. This is the force of attraction we are asked to look for when we have two charges Q1 and Q2 and distance separated is 2r. This becomes your formula in that case. So this is how to solve this particular problem. Let's do yet one more example and then we'll call it a day. So let's do one more example. Example 2. Example 2 says that what is the force of attraction between two charges Q1 has been equal to 5 microcoulomb and Q2 has been equal to 7 microcoulomb separated by distance. The distance there is 15 millimeter apart. Take K has been equal to 1 over 4 pi E naught, which is equal to 9 times 10 to the power 9 Newton meter squared per Coulomb square. So I'll ask to look for what is the force of attraction? That's F. So we're looking for what? F is unknown. So the task is quite easy as what? Recalling your formula and then that's all. So I have to recall, I'll recall that what do we know initially? We said that F is equal to K Q1 Q2 all over R squared. So my force of attraction F now will be equal to K. What's your K? In this case is what? This value 9 times 10 to the power 9. I have my K times Q1 Q2. Q1 is of course 5. Q2 is of course 7, right? All over R squared. I expect that my R should be in meters, not in millimeter. Convert 15 millimeter to meters. I have to divide by 1000. That becomes 0.15 meter, right? So in this question, my R now becomes 0.15 over the R squared. If I press my calculator, my F should be equal in value to 1400. Force is of course measured in Newton, so this becomes Newton. This is how you solve this particular problem under electrostatics. Do well to like this video, share to your friends and classmates, and also if you're interested in assisting or donating towards the cost of the progress of these videos, all right? So it's not easy, right? So if you're interested in assisting us by donating or making some amendments, some equipment available for us, you can reach me out through my WhatsApp number and then discuss. So do well to like this video, comment, share to your friends and classmates so they can learn too. See you in the next class.